laureates, distinguished guests, dear colleagues. It's my great pleasure to welcome you to the ceremony of the Nicholas Copernicus Polish-German Research Award 2026, a joint initiative of the Foundation for Polish Science and the German Research Foundation. My name is Katarzyna Pronobis, I work at the FNP, and today I'm delighted to host this event. I would like to extend a warm welcome to His Excellency Mr. Miguel Berger, Ambassador of the Federal Republic of Germany to Poland. Also to Professor Marek Konarzewski. Let me see if he joined us already or not. Not yet. But I would like to extend also my warm welcome to Professor Tomasz Dietl, Chair of the National Science Center Council, as well as Professor Bogumiła Kaniewska, Rector for Research at Adam Mickiewicz University in Poznań, the University of the Polish Laureate. I would like to also welcome Professor Katia Beka, President of the German Research Foundation, and Professor Grażyna Jurkowlaniec, Chair of the Council of the Foundation for Polish Science, together with Professor Krzysztof Pyrć, President of the Board of the FNP. I would also like to welcome our laureates, Professor Dorotej Harowska of Friedrich Schiller University in Jena and Professor Leszek Skrzypczak of Adam Mickiewicz University in Poznań. As I saw, both of you with many members of your family and other guests. Very warm welcome. I also welcome the members of the award jury and all representatives of academia, as well as partner and befriended institutions, especially representatives of the Zygmunt Zaleski Foundation, our long-standing partner in the Polish French Science Award. I also give a warm welcome to the authorities and all the staff of the DFG and FNP, as well as the guests who are watching us online on the YouTube channel of the Foundation. Today we celebrate something truly remarkable. Excellence in science, of course, without saying, but also trust. Trust between partners and cooperation that goes beyond borders. This award recognizes what becomes possible when brilliant minds from Poland and Germany join forces, not just to work side by side, but to challenge each other, to inspire one another, and to advance the frontiers of science together. To begin this ceremony, I would like to invite our hosts, representing both partner institutions behind this award. First, Professor Krzysztof Pyrć, President of the Foundation for Polish Science, followed by Professor Katia Beka, President of the German Research Foundation.
Thank you so much for being here. It is a great pleasure and a true honor to welcome you to Warsaw for the 11th time that the Nicolaus Copernicus Polish-German Research Award is granted. I am very glad to see Mr. Ambassador with us as a reminder that the scientific partnership we celebrate tonight is also a part of the wider relationship between our nations. On behalf of the Foundation for Polish Science and together with our partner, the German Research Foundation, the Deutsche Forschungsgemeinschaft, I thank you all for being here to celebrate something that lies at the very heart of our institutions. Excellent science and the relation between humans makes magic happen. Here I would like to note that could be no better patron for this award than Nicolaus Copernicus, a man of Togoń and of Europe. He studied in Krakow, Bologna and Padua. He belonged to the Republic of Letters and transcended political borders. He wrote in Latin, the language of science in his times, and he changed, quite literally, the way humanity sees its place in the universe. He reminds us that great science flourishes when ideas, talents, and curiosity can move freely across borders, and that knowledge is by its very nature a shared European endeavor. For 20 years, this award has carried his name as a symbol of what Poland and Germany can achieve when our finest minds work side by side. We live in a time when the value of science is sometimes questioned, and when cooperation across nations can no longer be taken for granted. That is precisely why this evening matters. At a time when Europe is redefining its scientific, technological and strategic future, Polish-German scientific cooperation remains one of the strongest foundations on which the future may be built. The Copernicus Award does not simply recognize individuals' excellence, it celebrates the partnership of researchers who choose to build knowledge together. It reflects a conviction shared by all of us here that the most difficult questions are answered not in isolation, but in dialogue. And so it is my great pleasure to endorse this year's laureates. Professor Dorothy Haroskę of the Friedrich Schiller University in Jena and Professor Leszek Skrzypczak of the Adam Mickiewicz University in Poznań. For nearly 2 decades and across more than 30 joint publications, they have worked together at the very frontier of mathematical analysis, in the theory of function spaces, in Fourier analysis, in the mathematics that underpins how we describe a sound, an image, or a physical process. Their work belongs to the finest tradition of fundamental research, yet its impact extends far beyond pure mathematics, influencing fields so diverse as medical imaging, numerical simulation, signal processing, and climate modeling. The jury honored not only the originality and significance of their scientific achievements, but also their remarkable partnership through conferences, workshops, joint projects, and the mentoring of young researchers. Professor Haroskę and Professor Skrzypczak have helped build a long-lasting network of cooperation between mathematicians in Germany and in Poland. Professor Haroskę, Professor Skrzypczak, your achievements, your partnership, and your commitment to scientific cooperation exemplify everything that this award was established to honor. This evening, however, would not be possible without the efforts of many people and institutions. I am deeply grateful to our friends and partners at the Deutsche Forschungsgemeinschaft and to its president, Professor Katja Becker, who is today with us, for a collaboration that has now spanned 2 decades. I thank the distinguished members of the jury for their expertise and dedication, as well as the colleagues at both our organizations whose work made this event possible. Finally, I would like to acknowledge the families, teachers, mentors, colleagues, and institutions who stand behind every scientific achievement. Let this award be more than a celebration of the past effort. Let it be an example to the next generation of Polish and German researchers to be bold, to cross borders, and to pursue questions whose answer can only emerge through collaboration. The challenges before us, the health, climate, energy, technology, security, and many more are complex. They will be addressed only by people who choose cooperation over division and curiosity over complacency. Thank you all for joining us this afternoon.
Yeah, Honorable Ambassador Berger, dear Christoph, dear presidents and rectors, distinguished guests, and of course, dear Professor Haroskę and dear Professor Skrzypczak, the new Copernicus awardees. This is actually the 11th time that we have come together to confer and celebrate the Nicolaus Copernicus Polish-German Research Award with the Palace of Culture and Science and the National Museum around the corner, right here in Warsaw. The Central House of Science and Technology is really a wonderful venue for this occasion. This bilateral award was jointly established over 20 years ago by the German Research Foundation and the Foundation for Polish Science. The renowned astronomer and physician Nicolaus Copernicus embodies pioneering science and the close cultural and academic ties between our countries. Through this award, we aim to honor exceptional researchers from Poland and Germany for their joint research achievements and to foster even stronger research partnerships. In fact, the strong, very valued, and, as you already mentioned, very trustful relation between Poland and Germany is of outstanding value, extending far beyond the academic sphere. Our countries are neighbors in the heart of Europe that is currently facing numerous challenges, both from inside and especially from the outside. In this context, internal strength and European cohesion are crucial for stability and competitiveness. Thanks to the manifold individual research collaborations, strong institutional partnerships, and joint activities of Polish and German research institutions and funding organizations, our scientific systems are really closely intertwined. Additionally, both our countries actually maintain strategies to further improve the excellence of research and their respective institutions. Consequently, the intensity of collaborative research continues to increase. This is how and why Polish-German research collaboration contributes significantly to the stability and attractiveness of the European Union. I would like to emphasize that it is basic, curiosity-driven research that can particularly help us make progress here. Investigator-driven research always holds the potential to expand our knowledge and lead to new discoveries. At the same time, it is an important symbol and product of academic freedom and the liberal democratic spirit, both of which are increasingly contested and yet over more important these days. By supporting the Copernicus Award together with FNP, we hope to strengthen Polish-German partnership, supporting our outstanding awardees as they continue their research and forge friendship and partnership across borders in the spirit of freedom and transnational collaboration. Biannually, since 2006, we have jointly honored one researcher in Germany and one in Poland from all areas of the sciences and humanities with the Copernicus Award. The awardees today, therefore, represent a broad spectrum of scientific disciplines and different career stages, and I think it's great that you were able to see them outside in one of the screen plays. Today, we have the great honor of presenting the 11th Copernicus Award to two very distinguished mathematicians. This is Professor Dr. Dorothy Haroske from the University of Jena and Professor Czubczak from the University of Poznań. They are both outstanding scientists who are internationally highly recognized, very well connected, and very well connecting. Their nearly 20 years of research cooperation in the field of analysis and partial differential equations has resulted in numerous joint publications in highly renowned mathematical journals and a series of specialist conferences they have organized together. Their collaborative work and expertise have addressed numerous mathematically challenging problems and fostered an inspiring environment that attracts most talented early career researchers, and this is actually where our future lies. Dear professors, may this award both recognize your joint achievements and inspire your future research. We hope it will also encourage you to continue promoting both Polish-German and European relations, embodying the value of friendship and excellence as substantially as you do. Congratulations.
Professor Becker, Professor Pirch, thank you very much for giving this context and also a vision of our future and a collaboration of our institutions, which is also very important. Now I would like to invite His Excellency, the Ambassador of Germany to Poland, Mr. Miguel Berger, to take the floor.
Sehr geehrter Herr Professor Pirtsch, sehr geehrte Frau Professor Becker, liebe Preisträger, Frau Professor Haroske, Herr Professor Skripczak, sehr geehrte Damen und Herren, es ist mir eine große Freude, heute hier in Warschau mit dabei sein zu können bei der Verleihung des deutsch-polnischen COPERNICUS Forschungspreises.
Szanowny Panie Profesorze, Szanowna Pani Profesorko, Szanowna Laureatko, Szanowny Laureacie, Szanowni Państwo, to dla mnie wielka radość móc dzisiaj uczestniczyć tutaj w Warszawie w uroczystości wręczenia Polsko-Niemieckiej Nagrody Naukowej COPERNICUS 2026.
Seit nunmehr 20 Jahren steht der Copernicus-Preis für wissenschaftliche Exzellenz, Neugier, Innovationsgeist und vor allem für die enge Zusammenarbeit zwischen Deutschland und Polen. Er erinnert uns daran, dass die großen Herausforderungen unserer Zeit nur gemeinsam bewältigt werden können, durch offenen Austausch, gegenseitiges Vertrauen und grenzüberschreitende Forschung.
Już od 20 lat Nagroda Copernicus jest symbolem naukowej ekscelencji, ciekawości, ducha innowacji i przede wszystkim ścisłej współpracy między Polską a Niemcami. Przypomina nam o tym, że tylko razem możemy stawić czoła wielkim wyzwaniom w drodze otwartej wymiany, poprzez wzajemny szacunek i realizując transgraniczne badania naukowe.
In diesem Jahr feiern wir gleich zwei Jubiläen. 35 Jahre deutsch-polnischer Nachbarschaftsvertrag und 35 Jahre Weimarer Dreieck. Beide Jubiläen erinnern daran, dass Versöhnung, Vertrauen und Zusammenarbeit nach Jahrzehnten von Krieg, Besatzung, Teilung nicht selbstverständlich waren. Sie sind zentrale Bausteine für die Stärkung der europäischen Zusammenarbeit zwischen Deutschland und Polen und Frankreich. 35 Jahre später stehen die Beziehungen vor neuen Herausforderungen, etwa in der Sicherheits-, Energie- und Migrationspolitik.
W tym roku obchodzimy dwa jubileusze. 35-lecie podpisania Polsko-Niemieckiego Traktatu o dobrym sąsiedztwie i 35-lecie powstania Trójkąta Weimarskiego. Oba te jubileusze przypominają nam o tym, że pojednanie, zaufanie i współpraca nie były czymś oczywistym po dziesięcioleciach wojen, okupacji i podziałów. Są kluczowymi elementami wzmacniającymi współpracę w Europie pomiędzy Polską, Niemcami i Francją. 30 lat później relacje te stoją przed nowymi wyzwaniami, przykładowo w obszarze bezpieczeństwa, polityki bezpieczeństwa energetycznej czy migracyjnej.
Wissenschaft und Forschung sind bedeutende Säulen unseres Dialogs und damit auch der deutsch-polnischen Zusammenarbeit, die heutzutage im Wesentlichen auf zwei Dokumenten basiert. Zum einen dem deutsch-polnischen Aktionsplan, den wir bei den letzten Regierungskonsultationen oder den vorletzten im Juli 2024 beschlossen haben und einer gemeinsamen Absichtserklärung.
Badania i nauka są filarami naszego dialogu i współpracy polsko-niemieckiej, która w dużej mierze oparta jest na dwóch dokumentach. Polsko-niemieckim planie działania, który powstał podczas przedostatnich polsko-niemieckich konsultacji, czyli w lipcu 2024 roku, i wspólnym liście intencyjnym.
Und die Früchte dieser engen und langjährigen Zusammenarbeit, wenn man so sagen will, auch der letzten 35 Jahre, und das sind durchaus wirklich beeindruckende Ergebnisse auch unserer Zusammenarbeit. 1542 Kooperationen zwischen deutschen und polnischen Hochschulen. Und damit ist Polen das mit Abstand wichtigste Partnerland der Hochschulkooperation in Mittelosteuropa. Zweitens, deutsche und polnische Wissenschaftseinrichtungen waren im Dezember 2025 auf EU-Ebene, zum Beispiel bei Horizon, gemeinsam an 977 Projekten beteiligt. Und damit kooperieren polnische Einrichtungen mit Partnern aus Deutschland am häufigsten, gefolgt von Spanien und Italien an zweiter und dritter Stelle.
Owocami tej ścisłej i wieloletniej współpracy, czyli tutaj 35 ostatnich lat, są między innymi 1542 kooperacje pomiędzy niemieckimi i polskimi szkołami wyższymi. Tym samym Polska jest z dużą przewagą największym krajem partnerskim w obszarze kooperacji szkół wyższych wśród krajów Europy Środkowo-Wschodniej. Polskie i niemieckie instytucje naukowe w grudniu 2025 roku wspólnie uczestniczyły w 977 projektach. Tym samym polskie instytucje współpracują najczęściej z partnerami z Niemiec. Kolejno z Hiszpanią na drugim miejscu i Włochami na trzecim.
Ein weiterer Leuchtturm dieser langjährigen bilateralen Zusammenarbeit sind die Dioscuri-Zentren für Exzellenz, die wir in diesem Jahr von 8 auf 10 Zentren erweitern werden. Die Max-Planck-Gesellschaft und das Nationale Wissenschaftszentrum in Polen führen das Programm gemeinsam durch, in dessen Rahmen herausragende Wissenschaftler und ihre Teams gefördert werden. Weiterhin die Deutsch-Polnische Wissenschaftsstiftung, die in den letzten 15 Jahren seit ihrer Gründung über 500 Projekte in Geistes- und Sozialwissenschaften mit über 140 Institutionen in beiden Ländern realisiert hat.
Kolejną latarnią tej wieloletniej współpracy bilateralnej są Centra Doskonałości Dioscuri, których sieć rozbudowujemy w tym roku z 7 do 8 centr. Niemieckie Towarzystwo Maxa Plancka i Polskie Narodowe Centrum Nauki wspólnie realizują ten program, w ramach którego wybitne naukowczynie i wybitni naukowcy i ich zespoły są wspierani w dążeniu do naukowej doskonałości. Kolejnym przykładem jest też Polsko-Niemiecka Fundacja na Rzecz Nauki, która podczas ostatnich 15 lat swojego istnienia zrealizowała 500 projektów wspólnie z 140 instytucjami z Polski i Niemiec.
Alle diese Projekte, die ich aufgeführt habe, sind ein Aushängeschild für Science Diplomacy und tragen mit der Wissenschaftsvernetzung und Forschungsförderung ganz maßgeblich zur besseren Verständigung und Zusammenarbeit bei.
Wszystkie te projekty od dawna są swoistą wizytówką dyplomacji naukowej i poprzez sieciowanie i wsparcie badawcze w swoistym stopniu przyczyniają się do lepszego zrozumienia.
Meine Damen und Herren, in den letzten 20 Jahren der Preisverleihung des Copernicus-Preises haben wir eine große Vielfalt an Wissenschaftlern und auch an Forschungsdisziplinen erlebt, die ausgezeichnet werden konnten. Es waren Pharmakologen, Biologen, Physiker, Informatiker, Mathematiker, Biochemiker, Mediziner, Astrologen, aber auch Geisteswissenschaftler mit dabei.
W ciągu 20 lat od pierwszego wręczenia nagrody w 2006 roku mieliśmy okazję doświadczyć ogromnej różnorodności wśród naukowczyń i naukowców oraz różnorodności dyscyplin badawczych, które zostały uhonorowane tą nagrodą. Wśród nich byli farmakolodzy, biolodzy, fizycy, informatycy, matematycy, biochemicy, medycy, astrolodzy, a także przedstawiciele nauk humanistycznych.
Für mich ist dieser Nachmittag, diese Preisverleihung auch ein Beispiel für eine der größten Errungenschaften zwischen unseren Ländern, die starke Verbindung, die entstanden ist, die Freundschaften, die zwischen Deutschland und Polen entstanden ist. Und vieles davon verdanken wir denjenigen, die Brückenbauer auch in der Wissenschaft waren. Und heute ehren wir 2 Brückenbauer aus dem Gebiet der mathematischen Analysis und der partiellen Differentialgleichungen.
Dla mnie to dzisiejsze popołudnie jest też swoistym przykładem takiego jednego z największych osiągnięć naszych krajów. Silnej więzi i przyjaźni pomiędzy Polską i Niemcami. Wiele z tego zawdzięczamy właśnie tym budowniczym mostów, także w nauce. Dziś uhonorujemy 2 budowniczych mostów w obszarze analizy matematycznej i równań różniczkowych cząstkowych.
Durch Ihre Arbeit, Frau Professor Haroske, sehr geehrter Herr Professor Skripczak, haben Sie eindrucksvoll gezeigt, wie wissenschaftliche Zusammenarbeit neue Ideen auch in der Grundlagenforschung hervorbringt. Ihre fast 20-jährige gemeinsame Forschung, die zu einer ganzen Reihe von Veröffentlichungen in renommierten Fachzeitschriften, einer Vielzahl von Konferenzen geführt hat, ist für uns, für mich auch ein großartiges Beispiel für die deutsch-polnische Wissenschaftszusammenarbeit.
Poprzez Państwa pracę, Pani Profesorko i Panie Profesorze, w imponujący sposób pokazali Państwo, jak współpraca naukowa przyczynia się do powstawania nowych pomysłów i przynosi korzyści naszym społeczeństwom. Zrealizowane przez Państwa już przez ostatnie właśnie 20 lat wspólne badania zaowocowały szeregiem wspólnych publikacji w renomowanych czasopismach, a także wieloma wspólnymi konferencjami, czyniąc z Państwa wspaniały przykład współpracy polsko-niemieckiej.
Ich möchte Ihnen beiden ganz herzlich zu Ihrem Erfolg gratulieren. Mein Dank gilt aber natürlich auch der Deutschen Forschungsgemeinschaft, DFG und der Stiftung für die polnische Wissenschaft, die diesen Preis nun seit 20 Jahren gemeinsam verleihen. Ihr Engagement zeigt auch sehr deutlich, wie lebendig und zukunftsweisend unsere wissenschaftliche Zusammenarbeit ist. Lassen Sie uns auch in Zukunft weiter eng zusammenarbeiten, um Wissen auszutauschen, Innovation zu fördern und die europäische Idee mit Leben zu füllen. Dankeschön.
Serdecznie gratuluję Państwu tego sukcesu i życzę wszystkiego dobrego na przyszłość. Słowa podziękowania kieruję także do Fundacji na Rzecz Nauki Polskiej oraz Niemieckiej Fundacji Badawczej, które już od 20 lat wspólnie przyznają tę nagrodę. Państwa zaangażowanie jasno pokazuje, jak żywa i nowatorska jest nasza współpraca naukowa. Proszę zadbać o to, byśmy także w przyszłości ze sobą współpracowali, byśmy wymieniali się wiedzą, wspierali innowacje i wypełniali życiem ideę europejską. Dziękuję bardzo.
Vielen Dank, Your Excellency. Ladies and gentlemen, we are now coming to a key moment of today's celebration. To introduce our laureates, I would like to invite Professor Paweł Strzelecki to the stage.
Good afternoon, everybody. My name is Paweł Strzelecki, and I'm a mathematician by profession and education. And I have been given an honor and this daunting job of presenting those two people and their work to you. Since I'm aware that there are about 5 or 6 professors of mathematics in this room, and the rest of you are non-mathematicians, I decided that I will try to tell you a little bit about what mathematicians do. And I will try to put their work in a certain perspective. Science is an old human endeavor, mathematics in particular. So in the history of, let's say, psychology or sociology, 10 years seems a relatively short period of time. In mathematics, the counterpart of 10 years is about 200 or 250 years. And my perspective will go far away back. So you've heard that they've written many papers together in prestigious journals. I'm not going to list the journals. I'm just going to tell you that they've written 31 papers, if I checked correctly, over the last 20 years. And when you start looking at those papers and you are a non-mathematician, then you will notice lots of names in the titles of the papers. So the most frequently mentioned name there is the name of Morey, Charles B. Morey, a US mathematician, often next to Biesov, a Soviet mathematician, but there are also other names. Tribel, of course, Lizorkin, Pitt, Mackenhaupt, and Fourier. And we are going back to Fourier, who was born in 1768 and lived for 62 years in the turbulent times of his era, was a mathematician, a physicist, and a very talented administrator in Département d'Isère. He was building roads there. But he was also investigating a physical phenomenon of heat flow in various materials. He wrote the first paper on heat transmission in 1807. In 1811, he got the award of the French Academy for his work, and finally in 1822, his book, La théorie analytique de la chaleur, appeared. And he is very well known for this book. And he had one excellent idea, an idea that profoundly influenced the whole of mathematics, and was very important later on in many guises. And this was the idea that every function, however complicated, think of the initial state of temperature in a maybe complicated body, every such function can be presented as a sum of simple sinusoidal waves with certain coefficients. And then when you have an idea like that, then you have several questions in the background. How do you construct such decompositions? How well do they approximate your function? In what sense, if you write down a series or a sequence of such approximations, are they convergent? And things take a long time in mathematics, and before we were able to tell a lot about Fourier series, many years passed, but they are behind at least two processes in the history of mathematics. The first one is the reconstruction of mathematical analysis by Weierstrass in Berlin in the 1860s. And the second one is something that profoundly changed the whole mathematics. This is the discovery of the set theory by Georg Cantor, who was also influenced by questions connected to Fourier series. And then, of course, people in the early 20th century were trying to solve lots and lots of partial differential equations, as we have heard today. And maybe I should stop here after Fourier and mentioning Weierstrass and Cantor and tell you where these two come from. So I will start with the lady, Professor Harowska. Her doctoral father was Hans Triebel, a very well-known expert in function spaces from the University of Vienna. His doctoral father was Mayer. Mayer's doctoral father was Carl Ludwig Siegel. And then via, I think, Landau and Fuchs, prominent German mathematicians, we go to Weierstrass, who was your grandfather, I think, if I'm correct. These are 7 or 8 generations of mathematicians. All of them working at the mainstream of mathematical analysis. When I look at Leszek Skrzypczak here, he did his PhD with Julian Musielak. And Julian Musielak did his PhD with Władysław Orlicz, who is the founding father of the mathematical analysis at the University of Adam Mickiewicz. Orlicz did his PhD in Lwów with Hugo Steinhaus, who did his PhD shortly before the First World War in Göttingen with David Hilbert. And somehow this mathematical school at Adam Mickiewicz University has a certain flavor of both Göttingen and Lwów in a very nice mixture, because Orlicz had experiences both of research and his own studies in Lwów, but then also of work in Göttingen. And maybe I should also mention that Steinhaus as a teacher was among the several great teachers of the Polish mathematical school. And his somewhat forgotten student was named Reichmann. He was a professor at my university here in Warsaw. And the most famous student of Reichmann, the very famous grandson of Steinhaus, was Antoni Zygmunt, who somehow at the very beginning of the Second World War emigrated to the US and was a creator of a huge school of harmonic and functional analysis there. And their work is somewhere in that stream. And who is Morey that they mentioned? So Morey is an American mathematician born shortly before the First World War, who died shortly before the Iron Curtain finally broke. A very famous guy working in partial differential equations but applied to problems that have some geometrical flavor. When Morey was close to 30, a beautiful age for a mathematician, the first Fields Medal was awarded to two people, Lars Alfors, a Finn, and the second one, Jesse Douglas, a US mathematician. And Jesse Douglas got this Fields Medal for solving the so-called plateau problem after 55 years or so. This is a problem that I can easily describe with my hands. Imagine a closed contour in the space. Every one of us was playing like that as a kid. And imagine that you want to span a soap film, like maybe you did in a bathtub. And you can always do this. This is the experiment that Plateau observed long ago in the 19th century. And Douglas confirmed this with a proof, and Morey was one of the people who were developing geometric analysis and this part of analysis in the 20th century. And that's it. I will not tell you about the CV of Biesov or of Lizorkin, but they are very interesting, believe me. You can look it up on the web. I will tell you something about collaboration. And I'm not going to use my own words. I'm going to use the words of Geoffrey Harold Hardy, a British mathematician, born in 1877, if I remember correctly. He died soon after the Second World War. And in 1940, when he was roughly my age, he wrote a book, A Mathematician's Apology, which is a sort of a testament of a thinker and an artist, a mathematician. It is witty, it is sharp, sometimes it is a little bit sad, and it is still one of the most vivid descriptions of how a mathematician thinks, and what we do. And I'm going to read you 3 short paragraphs from his last chapter. I still say to myself, when I am depressed and I find myself forced to listen to pompous and tiresome people, well, I have done one thing you could have never done, and that is to have collaborated with both Littlewood and Ramanujan on something like equal footing. I have never done anything useful. No discovery of mine has made or is likely to make, directly or indirectly, for good or ill, the least difference to the amenity of the world. I have helped to train other mathematicians, but mathematicians of the same kind as myself, and their work has been, so far at any rate as I have helped them to do it, as useless as my own. Judged by all practical standards, the value of my mathematical life is nil, and outside mathematics, it is trivial anyway. I have just one chance of escaping a verdict of complete triviality. that I may be judged to have created something worth creating. And that I have created is undeniable. The question is only about its value. The case for my life, then, or for that of anyone else who has been a mathematician in the same sense in which I have been one, is this: that I have added something to knowledge and helped others to add more, and that these somethings have a value which differs in degree only, and not in kind, from that of the creations of the great mathematicians, or of any of the other artists, great or small, who have left some kind of memorial behind them. I want to sincerely congratulate you.
Thank you very much, Professor Strzelecki, for the great laudation and much more. Thank you. I would now like to invite once more Professor Becker and Professor Pyrć, and of course our laureates, for the presentation of the Copernicus Awards diplomas. Let me check if our photographer is already ready with all the pictures planned. Please give us a few seconds more. I think it's always good to praise everybody with the clap. So. Great. Thank you, Professor Becker. Thank you, Professor Pyrć. And I would like now invite our distinguished laureates to share a few words with us. The stage is yours.
Dear Mr. Ambassador, Excellency Miguel Berger, dear Mrs. President of the German Research Foundation, Deutsche Forschungsgemeinschaft Katja Berger, dear Mr. President of the Foundation Foundation for Polish Science, Krzysztof Pyrć. Okay, thank you. Dear guests, dear colleagues and friends and families. So, Leszek, according to the program, it's time now to express our deep gratitude to those people who supported us on our way to this wonderful event. I think we have 5 minutes, but I guess the very short version of our thanks will last for at least half an hour. Do you think this is okay in view of our 20 years of collaboration?
Okay, Dorothy, I think we should start from the very beginning. So, I do not mean our parents or grandparents or grandparents. No, if I recall it correctly, you are the 21st or 23rd generation depending on the academical path, after Copernicus. And I am 22nd generation after our joint mathematical ancestor Copernicus. But to be honest, according to these databases, he has more than 250,000 descendants nowadays, and probably a lot more. So this may not be really explained why we started to collaborate. And moreover, why only we are here today. Nevertheless, thanks to Copernicus for setting the scene somehow that paved the way for us to receive this award today.
More personally, we would like to mention and thank our academic supervisors, Professor Julian Muzielak and Professor Hans Triebel. I guess that both were also responsible for getting us fascinated to the topic of function spaces in one or the other approach. And it was also due to Hans Triebel that you started a postdoc position in Jena in his group about 30 years ago, where I was a PhD student at the same time. So here are also some belated thanks to the German Research Foundation, again, as they financed the research training group in Jena, where your postdoc position belonged to.
Thanks.
However, we did not start our collaboration then, but about 10 years later only. In any case, we met first time in Jena and found ourselves interested in the same topic, function spaces.
By the way, there's also another shortcut with Hans Triebel and the event today. I recall that Hans Triebel has always been fascinated with important mathematicians in history, like Gauss, Hilbert, Banach, and Copernicus. And as far as I remember, he always suggested me that on the Polish €1 coins, there should be definitely the Copernicus. I couldn't promise it.
We very much appreciate the apparently positive recommendations from other reviewers and the Commission, and the very generous decision by the German Research Foundation and Foundation for Polish Science, DFG and FNP. We are still overwhelmed by the outcome and also the impressive event today.
But special thanks, however, are dedicated to our colleague, Tino Ulrich, who last year found out details about this Copernicus Award in some news of the German Research Foundations and approaches us with his idea to nominate us. We have to confess that we were not very optimistic at all, but he was quite persevering and finally convincing with that idea. We know that he really wanted to be present here today, but not organize his other duties in that way. Thank you very much, Tino. You are right after all.
We also would like to thank our recent and present co-authors and colleagues all over the world, in particular Fernando Cobos from Madrid, Thomas Kühn from Leipzig, Winfried Sickel and Hans-Gerd Leopold von Jena, Susanna Mura from Coimbra in Portugal, Mirtek Mastivo from Poznan, Cornelia Schneider from Nuremberg, David Edmonds from Sussex, Jan Wüberal from Prague, Dachong Yang and Wen Yuan from Beijing, and Agnieszka Kalamajska from Warsaw, and many others. They posed us a lot of interesting questions, motivated and inspired our research, and are kind enough to read and use our results.
Dorothy, we should not forget to express our thanks to God for creating a growing coffee trees. Why? There's a still popular quotation usually attributed to the famous Paul Erdős, stating that a mathematician is a machine for turning coffee into theorems. This is definitely true in our case. Indeed, we wonder how mathematician could work before drinking coffee was invented.
Last but not least, we are much obliged to our families for their almost never-ending patience and support also today. Without their broad-mindedness whenever we went away for some conference or workshop, or returned home later than planned from the office, or spoke longer than expected,
or even were present but lost in thoughts, probably in the middle of some proof or counterexamples, without all their deep understanding and love, we would not be here today. But fortunately we are, and we can enjoy it all together. What a wonderful day.
Thank you.
Thank you very much for this nomen omen bilateral speech, and humorous and very heartwarming. Thank you so much. We need now a minute to rearrange the stage because we are going to have a conversation, and therefore let me now invite on stage Dr. Anna Plater-Zyberg, the Vice President of the Foundation for Polish Science, who will conduct an interview with our laureates.
Thank you so much, Kasia. Thank you. Good afternoon, everybody. It's my great pleasure to sit down with both laureates of the Copernicus Award for a short conversation that we have planned on the nature of your scientific collaboration, on the future of mathematics, and on the impact of artificial intelligence on research. We only have 15 minutes for that, so I would like to invite you all to treat it more like a trailer and invite you to read a longer version of the interview that our colleagues Karol Jałochowski, who's here with us, organized with laureates, and this interview is available on our website. Now, without further ado, I would like to move on to our first question, and I would like to ask you, what did receiving the Copernicus Award mean to you personally?
It was just overwhelming and stunning and completely not expected, as I really have to say, as were in all things. And even more, it was so wonderful as when we started our collaboration, I think at least me, but probably we both never had in mind to get some award for this. We just liked doing research together and discussing questions or disproving some things. And so this was really very nice and it is still very nice to do this. And I have to admit that at some very little part, it's also some tiny satisfaction for me with some other colleagues who always thought that we are doing things that nobody really is interested in. But most of them are very kind and congratulated.
Thank you so much. And you, Professor Skrzypczak?
More or less the same. What can I add? I think, well, I can say something like that. There's a big difference between doing the professional sports and doing the professional mathematics. If you are doing the sport, you won't be the winner. If you are doing mathematics, you want to explain something, to understand something, to discover something. And if you achieve success, then maybe some award come, and there's just additional benefits.
Okay, thank you so much. Actually, using this metaphor, I would like to go back to one part of the interview that was mentioned before. So the discussion that you had with Karol, you mentioned in this conversation that your collaboration is a little bit like a relay race, that first one person is working on one topic and then sending it to the other person, and then you are working with students and teachers while the other person is moving forward with the question. Would you say it's a typical thing for mathematicians to do, or is something unique for the way how you work together?
So I think we live in times that we have in situations that it is very easy to communicate in over distances. And this changed the style of collaborating, surely, definitely. So I think that it is now quite usual that people work in that way. So send one to another some results of what they done. And in mathematics, we do not need an experiment, so we do not need so much to be together. Just, it is of course sometimes very fruitful to meet, to discuss, especially at the very beginning of the project, but then we can continue just sending our results.
Okay.
Well, I think it probably, as far as I know, my colleagues, it's not so unusual, in at least this theoretical part, that people, if they have found somebody who they would like to work together and have the same attitude to discuss things, that they continue in that way. I mean, about one of our very frequent colleagues is sitting in Portugal, and then as you said, with a relay idea, we have teaching periods at different time. So if we don't meet, but then at least one of us, the three of us, or one of the two of us, depending, has maybe a little bit more time to continue and to discuss, and then asking questions again. So I think it is, of course, we are here now, getting the award today, but it's not so unusual, at least in this theoretical part of mathematics, I would say.
Okay. And building on what you said, that you work in different countries, in different institutions, would you say it is an added value in doing research? Does it help that you are from different countries? Does it help that you are Polish and you are German? Or it doesn't have any impact on doing mathematics, that you are based somewhere else?
Yeah,
even though you have grandfathers in common.
Well, I think that we come from different places or different nations, at least in this part of mathematics, doesn't really make a big difference, I would say. As the attitude, how to address problems or to work on these, might be different between people sitting next door, or sitting in China, or in Germany, or in Poland and Germany. I think and on the other hand, there's this very close history that you have heard also in this speech of Professor Streletsky. So I think in our area, the history and functional analysis is closely related to people from Poland and from Germany, even before the war, I think. So we come from that sense, from the science here, I would say from a similar tradition rather than from a very different one. So I don't know, how do you think? But
well, I think that first of all, mathematics is the universal language. So two mathematicians can work together just over the world. And we have, I think, all mathematicians, a common standard. To simplify a bit, it is the legacy of Euclid and Archimedes and other Greek mathematicians. And this helps very much to collaborate independently from which country you are.
Thank you. So let's move on now to what is on your mind today. And I would like to ask you if there is still a research goal or discovery you would like to especially achieve.
I think we have some virtual to-do list, which is always in the back of our mind, and we ask ourselves from time to time whether it's now time to solve a problem or to get something new. So in principle, I think that we get motivation from outside, that people ask us questions where we also refer to in the thanks a little bit, or that there are some generalizations, but usually it is not that we really just look for something to generalize and nobody's really using this. But I think in some sense, maybe this a bit too pathetic, but nevertheless, what you really would like to know is why is it like that? Why is something working in this way? To understand, Goethe was living near Jena, where I come from. And so what is the innermost reason that takes the world going, towards what takes the mathematics going? And I think this is something that at least we share in an interest to really understand not only that something is true or not, some theorem, of course we have to prove it, but why is it true and what does it tell us? But
it is difficult to answer this question, not to be a bit technical. I mean, the question is what I have in mind. So I think that there are some ideas that are important for us for years, and they are still important. For example, such as general ideas like local and global. Some properties can appear both in local and global version. In some applications, they are more useful in global version, sometimes in local version. There's a question why. We are also more technically, we are always interested in the compactness and continuity of some mathematical procedures. Compactness is more useful, but not so common. More useful in applications. So we think about studying some properties that are a bit weaker than compactness, but still have some applied features. Oh, sorry for this.
I think I understand some of it. And what about artificial intelligence? Do you think about it? Artificial intelligence is changing field after another, and are you thinking about how it's going to impact mathematics? How it's going to impact your way of doing mathematics?
First of all, we are not specialists in AI, and up to now we have not used AI in our investigations. This is the first thing. And to answer this question, I should know two things. First, what is mathematics? And the second, what is AI? And this is not so easy for me, the both. Well, mathematics is maybe a bit easier because we can simplify the answer saying that mathematics is the result of the work of the mathematicians. So that means the result of the coffee drinking. But AI is a field that changes so quickly, so rapidly. And the tools of AI have, from the one side, superhuman power. On the other side, shows bizarre weaknesses, makes really silly mistakes, and also on the field of the mathematics. So it is really difficult to answer, to predict the future. Maybe we will have the new discussion about what is the mathematical proof, what ingredients constitute the mathematical proof. From time to time, such the discussion took place in the history. The last one, something like 50 years ago, when the people use some computer algorithm to prove focal so-called focal theorems. So I expected something like that for the future. But on the other hand, we should be very careful because, for example, on the beginning of the 20th century, people expected that the axiomatic approach plus the human ability, human intelligence leads to the solving any mathematical problem. There was the famous radio broadcast by David Hilbert. He said then the famous sentence, "Wir müssen wissen, wir werden wissen." We must know, we will know. And a year later, Kurt Gödel showed that he was wrong, that the situation is much more complicated than Hilbert expected. So we should be careful, I think, speaking about the future.
And maybe returning to our personal experience of this, I mean, there's now a big discussion and maybe a big change. You heard that we have published some papers in prestigious journals, and usually up to now it is the version that you send something there and then other experts write down their opinion, and then this is somehow proved and published. But everything is written down. But now there is a big challenge and maybe also a concern among our colleagues that this will be more or less done automatically, or the idea is that to do it automatically, to review things. And of course, it's much quicker, but it's not transparent in that way, as you cannot trace it back in the end, why this was neglected or rejected or approved of whatever, as this is fluid, it's a way. And so I think there's the big pressure, in particular from the publishing houses, say, that to make it everything very cheap, very quick. But to what extent? What is the price to pay? I mean, so far we still had the idea that in principle we could trace back all the results that we use to the very beginning. But then, so I think there's quite some challenge, and I can understand the desire of the publishing houses, but I'm not so concerned, I'm not so convinced that the AI is the solution to this.
Okay, thank you so much. So the future of mathematics is safe.
Sure. As long as there's enough coffee, I mean.
Okay, thank you so much. I have a couple of more questions on my list, but unfortunately we are running out of time. So we have to wrap up here. Thank you for all your time. Please join me in thanking our laureates once again.
Thank you very much for sharing your thoughts, but also feelings and dreams with us. Thank you, Anna, for hosting this interview. And to conclude the official part of our ceremony, I would like to invite once more Professor Krzysztof Pyrć for closing remarks.
Thank you so much. I was asked to conclude the meeting and to summarize it. It's always very difficult because when I'm writing what I want to say, I don't know what others will say, so I will improvise a bit. So to start with, I would like to wrap up on what we heard, on what we experienced today here. So first, we experienced excellence, scientific excellence in mathematics. I'm not going to pretend I understand this. I'm a scientist, but not in mathematics, so it's very, very complex. I tried to read through the papers, but it was a bit too far. But the discoveries are really striking and really breakthrough in the field of mathematics. And actually, as I said in the beginning, they added a lot, not only to general knowledge, but also to our everyday life. And then referring a bit to AI that was discussed just a minute ago, I had this thought in my mind that AI is very good at answering questions, but it's very bad at asking questions. I cannot imagine the AI asking why sky is blue. It can answer us why, but it will not ask this question. And that's where the scientific excellence and the fundamental science is, asking questions and inventing things that are not yet here. Second thing we have witnessed today was collaboration, and we could see that it's not a collaboration on paper. It's very difficult to say what collaboration is in the written text or just in the speech, because then if you say, well, 20 years of collaboration, 31 published papers, but it does not reflect what we experience today. You could see that yourself, two people working together while living in different places. And Anna, the question you asked, whether there is a difference working with somebody from another country, I think the point is that we need to find a second person fascinated in the same thing. If we're open to the world, we have a chance to do that. If we are closed, we are alone. So I don't think that we differ between Poland, Germany, China, Russia, and the US, but I think we have to find the second person. The better the world is, the higher chance we have to do that. But there is also a third thing we witnessed today, because there is something more. Today we did see the act of scientific diplomacy. This has been mentioned by Mr. Ambassador and Professor Becker before, but I think it needs to be underlined, because the world has changed. Russia's invasion of Ukraine has redrawn Europe's security map and forced a painful unwinding of long-standing scientific ties. Intensifying geopolitical competition has reshaped now how universities think about open science, about dual use, about who walks through whose doors. The politics in science across all disciplines has become a recurring challenge, often accompanied by constraints of academic freedom. Funding tightens, visas stiffen. The temptations of academic protectionism push quietly but persistently in the same direction, inward. We are getting more and more isolated, and there is a risk this trend will become even stronger. In such a time, scientific diplomacy is not an alternative to diplomacy. It is something more particular and in the long run, more durable. It's not a substitute for foreign policy, but it does what more formal channels often cannot. It builds relationships at the level where ideas circulate. It speaks a language of evidence and shared problems that travel across changing political climates. And it produces a quiet infrastructure of trust that no treaty can manufacture and no crisis can quickly destroy. And the place where this trust is actually built, where scientific diplomacy takes root, long before it even appears in any institution, is in fundamental curiosity-driven research. It is also where the resilience of nations is being built. No aircraft will fly without physics, without scientists that worked with no means to commercialize aircraft. No computer would exist without centuries of chemistry pursued for its own sake. The therapies that today save lives, we used to lose rest on biology and biochemistry done long before anyone could name the disease they would one day cure. And the technologies of our successors will depend on today, on the curiosity of the researchers whose grants were not even written. This, in the end, is what we have also honored tonight, these three things. This was a working demonstration that two democracies with a difficult short history can become, through long and disciplined effort, indispensable partners in making of knowledge. Professor Hareske, Professor Skrzypczak, one more time, and from everyone gathered here this evening, our warmest and most heartfelt congratulations. I'm truly hoping that the award of 200,000 euros from DFG and from FNP will help you to continue this collaboration, and we hope that this will bring even further fruits. Thank you to all the guests, thank you to all of you, and have an excellent evening.
Thank you very much, Professor Pyrć. Ladies and gentlemen, this brings us to the end of the official part of the ceremony. We would like to thank all the guests who have been watching us online.
Fling the rumba drum.